Today's Daily Dose of Math is about the parallelogram. Here we're covering the basics of a parallelogram. And we look at the definition of a parallelogram. A parallelogram is a quadrilateral that has two pairs of opposite congruent sides. This shape is a parallelogram, and it is following the rule in the definition. These two little lines on the shorter sides are a way of indicating that they are congruent. They are equal in length to each other. And then the pair of double lines on the two longer sides shows that they are also congruent to each other. In this case, the longer sides are not the same length as the shorter sides, but that's not necessary for it to be a parallelogram. This shape is a parallelogram. We're comparing the parallelogram to the trapezoid, and we're asking the questions, is a parallelogram also a trapezoid? And is a trapezoid also a parallelogram? On the left, I have a parallelogram. These two lines on the shorter sides show that those two sides are equal in length. And these two pairs of double lines on the longer sides show that those two sides are also equal in length. On the right, I have two trapezoids. One of them is an isosceles trapezoid. These two little lines show that two of its sides are equal in length. The other one has two internal 90-degree angles, as shown by these little angle squares in the corners. But in order to know for sure that this is a trapezoid, we need more information. So in this little box, we have a bit of extra information. It tells us that sides AB are parallel to sides CD in both of the trapezoids, and that side BC and side AD are not parallel in both of the trapezoids. Now let's look at the definition of a parallelogram. Parallelogram is a quadrilateral that has two pairs of opposite congruent sides. We can see that our light gray parallelogram is following this rule. It is indeed a parallelogram. But neither of the trapezoids are following this rule. In the one on the left, we have one pair of opposite congruent sides, but the other pair are not congruent. In the one on the right, we don't have any congruent sides in this trapezoid. Therefore, because the two trapezoids are not following the rule in the definition of a parallelogram, neither of them is a parallelogram. Trapezoids are never parallelograms. What about the parallelogram? Is it also a trapezoid? Let's look at the definition for a trapezoid. A trapezoid is a quadrilateral with a pair of opposite sides that are parallel and in which the remaining pair of opposite sides are not parallel. Warning: this is the exclusive definition for a trapezoid. So called because it excludes certain other shapes from being trapezoids. There is also an inclusive definition. But in the curriculum in which I teach, we are using the exclusive definition. Both of these orange trapezoids are following all of these rules, and therefore they are indeed trapezoids. In order to be sure of that, we needed that extra information in the box. But the parallelogram is not following the definition of a trapezoid. It has a pair of opposite sides that are parallel, but the other pair of opposite sides are also parallel. To be a trapezoid, they would need to not be parallel. So therefore, the answer to our questions is parallelograms are never trapezoids, and trapezoids are never parallelograms, so long as you are using the exclusive definition for a trapezoid. Is a rectangle also a parallelogram? And is a parallelogram also a rectangle? We have a green rectangle here that shows it has two pairs of opposite congruent sides and four internal 90-degree angles. And we have a purple parallelogram that shows it has two pairs of opposite congruent sides. Looking at the definitions, parallelogram is a quadrilateral that has two pairs of opposite congruent sides. This rectangle is following that rule, and that means that all rectangles are also parallelograms. A rectangle has two pairs of opposite congruent sides and at least one internal 90-degree angle. This parallelogram is following the first part of that rule, but not the second part. It doesn't have any internal 90-degree angles. But a parallelogram can have an internal 90-degree angle. Therefore, some parallelograms are also rectangles. Final answer to our question: All rectangles are also parallelograms, and some parallelograms are also rectangles. Is a rhombus also a parallelogram, and is a parallelogram also a rhombus? Our blue rhombus has little lines that show it has 4 congruent sides. Our green parallelogram has lines that show it has 2 pairs of opposite congruent sides. Looking at the definitions, to be a parallelogram, it has to be a quadrilateral with 2 pairs of opposite congruent sides. The blue rhombus can be said to have 2 pairs of opposite congruent sides. All rhombuses, because they have 4 congruent sides, can be said to have 2 pairs of opposite congruent sides. That means all rhombuses are also parallelograms. A rhombus has to have 4 congruent sides. This green parallelogram does not, so it is not a rhombus. But a parallelogram can have 4 congruent sides, so sometimes a parallelogram will also be a rhombus. Final answer to these questions: all rhombuses are always parallelograms, and some parallelograms are also rhombuses. Finally, let's look at the square. Is a square also a parallelogram? And is a parallelogram also a square? This blue square has 4 congruent sides and 4 internal 90-degree angles. The purple parallelogram has 2 pairs of opposite congruent sides. Looking at the definition of a square, it has to have 4 congruent sides and at least 1 internal 90-degree angle. So the purple parallelogram is not a square. But can the parallelogram be a square? Yes. A parallelogram can have an internal 90-degree angle, and it can have 4 congruent sides. So some parallelograms are also squares. Looking at the definition of a parallelogram, it is a quadrilateral that has 2 pairs of opposite congruent sides. This square and all squares, because they have 4 congruent sides, can be said to have 2 pairs of opposite congruent sides. That means all squares are also parallelograms. The answers to these questions: is a square a parallelogram? Always. Is a parallelogram also a square? Sometimes. That is today's Daily Dose of Math. Please like, subscribe, and share.